length tension relationship of a muscle fiber. Relationship of muscle fiber. So in this length tension relationship, so here one side we are taking tension, and x-axis we are taking length of the muscle. This is length of tension of the muscle fiber, only on muscle fiber. We are taking on muscle fiber. Suppose if you see center, this is the optimal length. This is the optimal length of the muscle. Optimal length of the muscle. In the optimal length, observe this point. In the optimal length, if you observe, this is our myosin, thin filament, thick filament. This is our actin, thin filament. So the space between, see here, the overlap between actin myosin is there. Overlap between actin and myosin is present here, but it is less. So that is called optimal length of the muscle. At this optimal length, the force, mean the tension which is there inside the muscle, it will be more. See, at this optimal length, the tension will be more on the muscle. The muscle can be able to generate the maximal isometric tension. Okay, this is the point. Now if you see now if we see eccentric contraction, see this is eccentric contraction, this is this side concentric contraction, eccentric contraction. When we are doing eccentric contraction, nothing but lengthening of the muscle. The space, mean the overlap between, see here sarcomere, mean actin and myosin is reduced compared to this one. Here overlap is little reduced, so that the tension will come down. In the muscle fiber. If we do little more eccentric contraction, if we do, the overlap between this actin myosin won't be there, so that tension will come to zero. This is about eccentric contraction. So that here, if the overlap is there between actin and myosin, then some tension will be presented. If there is no overlap, means there is no tension. Now we will come to concentric contraction. If we come to concentric contraction, here this is the shortening of the muscle. Here the overlap between actin myosin is almost maximum between overlap between, see here space is there between actin and myosin in the middle, but here actin is completely over the myosin, so that here the muscle length is reduced. This is concentric contraction. In this also, the tension will come down. The tension on the muscle fiber will come down. After that, if we do little more concentric contraction, here the first point, actin will overlap the myosin. Okay. Second point, this actin is going to overlap this actin. Otherwise, this actin is going to overlap this actin. So that much force will be, that much sliding will be happen. This actin will come like this. This actin will be like this. So it is extreme concentric contraction of the muscle. So that if it happens here in sarcomere, the tension which is there inside muscle, it will come down to zero. This is the point. So at the optimal length of the muscle can able to generate the maximal isometric contraction. If the sarcomere is, if the actin myosin, this is if actin myosin, the space is increasing here, then the force, tension will come down to zero. If it is actin myosin overlapping more also, force tension overlapping more also. If actin myosin also overlapping more, that time also tension will come to zero. This is about length tension relationship. Okay.